All right, hello and welcome to this lesson on simplifying radicals. This should be the second lesson in term 3. So let's move on with this. So in this lesson you should learn how to simplify radicals using rules of exponents. So this is something we talked about in lesson 1. And we're going to kind of focus more on the simplifying. And then also being able to write radicals using exponents. This is going to be our main goal in this lesson. Okay? So let's move on to the lesson, I guess. Okay, so some radical vocabulary. A rational exponent is just an exponent that is a fraction. So we're going to start getting some writing radicals in exponent form. So a radical is just a function that says some number multiplied by itself n times equals the radicand. So if I have something that says, like, say, the square root of 16, that means that I have some number multiplied by itself 2 times will equal this number underneath the radical. And we know that's 4 multiplied by 4. Okay, the radicand is just the expression underneath the radical. And the index is the root number. It's that number that's in the nook of the radical. We see it down here. That tells how many times a number needs to multiply by itself to equal the radicand, the number underneath the radical. If it's not noted, we say that that index number is 2. Okay, so simplifying a radical expression. We're going to create a factor tree like we see right here in the green. We know that 16 we can factor down to be 4 multiplied by 4. I usually cancel this out after I write down my factor tree. And then we're simply going to say, well, I know that I need to find what multiplies by itself 2 times. I have my group of 4, and I pull it up here, saying 4 multiplied by itself 2 times. If you notice, though, you see that I have this plus or minus 4. That's because I don't know if it's a positive 4 multiplied by a positive 4 to get 16, or if it's negative 4 multiplied by negative 4 to get a positive 16. So we have to say plus or minus because we don't know. We have to cover both bases. Okay, I want you to try. So please pause the video at this time. Give this one a try. It shouldn't take you too long. All right, perfect. Welcome back. Hopefully you paused the video, you tried it. We're going to go over it really quick. So I have 25. Well, we know that it's 5 times 5. I cancel that 25 out because we've already factored it down. I'm looking for something that is multiplied by itself twice. So I have 2 5s there. So I get plus or minus 5. There's my answer. All right, let's move on to the next one. Sometimes my PowerPoints don't want to work, and that's all right. We're not going to judge you too hard. All right. Here's just a quick list of perfect squares and perfect cubes. These are ones that are pretty common that show up. They're the first 15 perfect squares and the first 10 perfect cubes. Sometimes they can help us simplify a little bit faster. Take a minute to write them down, pause the video, go back to the PowerPoint, jot them down. Okay. So in math, anytime we can perform some sort of operation or function, there's always a way to undo it. Well, we've learned about exponents, we've learned about radicals, and they actually undo one another. They're opposites is what we would think of them as. So this is what we're looking for. Remember, I have my index number here and my exponent right here. So what we know is that if my index number and my exponent are the same, so I'm saying if I looked at this function right here, or this expression, we would say the square root of a squared. So the square root is being squared. That square root and squared cancel each other out, and I'm left with just a. So the same thing is going to happen here. My index is the same as my exponent. So I just get what's underneath the radicand, which is my a. Underneath the radical, which is the radicand. Okay, so just a quick review. If the index is the same as the exponent, then they will cancel one another out. Okay, so that's an important piece of information. Okay, exponents and radicals. So we can actually write radicals in rational exponents. So that means that they are exponents that are fractions. Okay, so for example, if I look down here and I have the square root of a, I can rewrite that as a raised to the 1/2 power. So I look at this right here, this a. This now becomes my base value. So there's my a. Right now I just have a 1 raised to the 1 power. This becomes my numerator. So there's my numerator. And then my little number, my index number, this is going to become the denominator right here. Okay, so we're going to play with that going back and forth. Alright, so right now I have the cubed root of x raised to the 4th power. Okay, I feel like I skipped something here. Did I? No, perfect. Alright, you get the unedited version of this video. Alright, so I want to rewrite these exponents. So I have the cubed root of x to the 4th. So I'm going to look at this real quick. This first one. I know that x, that radicand number, that is going to become my base. So I still have x. Then I look to the exponent of that base number, and that's going to become my numerator. So x raised to the 4, that 3 becomes the denominator. I don't know why I have dem right there. Denominator. So I would rewrite that as x raised to the 4/3 power. Next, I have the square root of x to the 5th, so we're going to do the same thing. My base is right there. X. My 5 becomes my numerator. And then I have a 2 right there. Remember, if nothing's written there, it means it's a 2. And that becomes my denominator, 5/2. Okay, let's look at this last one. Maybe pause the video, check it out. Alright, here we go. So I have x raised to the 8/4 power. Well, I know that I can simplify that 8 to the 4th. That's going to simplify pretty easy. We just get x squared. 4 goes into 8 2 times, so we can simplify that. Alright, so let's simplify these radicals. Okay, so what I'm going to do is I'm going to start with 27 raised to the 1/3. I don't always know what that 1/3 power is. It's still weird. I'm not used to that rational exponent yet. So what I'm going to do is I'm going to rewrite it into something that we kind of already know. The cubed root of 27. Now what I can do is I can break this down into a factor tree. So I always start with 2. Can 27 be divided by 2? Nope, I can't. What about 3? Yep, 3 goes into 27. So I'm going to take 27 and I'm going to divide it by 3. 3 times 9 is 27. I'm going to cross out that 27 so I know that it's gone. I'm good with 3. 3 times 1 is as low as I can go. And then 9 here, I can go 3 and 3. I cross out 9 because I'm used to it. Now I'm looking for some number multiplied by itself 3 times. So I'm looking for a number that appears 3 times. So I see my group of 3 right here. And I know that a 3 can come out. There's nothing left over, and so I know that it's just 3. So the cubed root of 27 is equal to 3, or 27 raised to the 1/3 power is equal to 3. Next, we're going to move to 144 raised to the 1/2 power. So once again, I'm going to rewrite this into a form that I better understand. So I'm going to say the square root of 144. We're going to do the exact same thing. I'm going to first see, can I divide by 2? I can. It's an even number. So 2 goes into 14 7 times, 2 goes into 4 2 times. Cross that out. Keep going down. I can divide by 2 again. 72 divided by 2 is 36, and you can use a calculator for this part. Now, same thing, can divide by 2. I'm going to keep going this because remember our goal here is we want to find some number multiplied by itself. So I'm going to try and go with 2 as long as I possibly can. 36 divided by 2 is 18. 18 divided by 2 is 9. Oh, my run of 2's is out, but 9 can go 3 times 3. So I'm looking to find the same number, and I'm going to do groups of 2. So I have 2 2's right here, 2 2's right here, that 9's gone, and a group of 3 right there. So what I get is 2 multiplied by 2 multiplied by 3, and I'm using these groups to find those. Okay, 2 times 2 is 4, 4 times 3 is 12. Now if you notice from the very start that you could have said 12 times 12, perfect, you saved a bunch of work. But if you don't see that, that's okay, because I can use this process, and it just takes a little bit longer. It's not too bad. Okay, so we're going to do the exact same thing now, but this time we're going to do number 3, this 512 raised to the 1/3 power. So I have the cubed root of 512. Okay, I'm going to do the same thing. I'm going to divide by 2 here. So 2 goes into 5 2 times. I believe it's 256. And then I get 2 and 1. 5 goes in twice, 16 8. And I get 2 and 64. I'm going to kind of just go off to the side here. 2 and 32, 2 and 16. See, this is where understanding how that 512 breaks down would really help. 2 and 8. Oh man, I got to keep going. 2 and 4, 2 and 2. So I got to be a little bit careful here because I got kind of all over the place. So I have a group of 2 here. I have a group of 2 here. Group of 2 here. I feel like I'm missing something. I got a little scattered here. A group of 2 here. 2, 4, 6. I feel like I missed something. That's okay though. So we're gonna say I have 1, 2, 3 groups that I can see, and 1 left over. So let's just kind of see what happens. 4, 6. So I have 2 multiplied by 2 multiplied by 2. So that's represented in these 3 groupings of 2. And I still have, right now I'm showing that I have 1 left over. I'd have to like make this a little bit more organized for me to see. And I'd get the square root of 2. So I get 2, 2, 2 is 2 times 2 is 4. 4 times 2 is 8. So my answer would be 8. Let's delete that a little bit. 8 square roots of 2. And that's the answer. So what I'm going to do real fast, so I'm going to switch over to another page. I'm going to make sure that we got that 8 square roots of 2, just so I can be a little bit more organized. So what I have is the cubed root of 512. So 512 divided by 2. I'm going to pull out my calculator just to make sure I'm doing this right. 512 divided by 2 is 256. Divided by 2 again is 128. Divided by 2 again is 64. Then we get 32. And then after that we get 16. And then we get 8. Then we get 4. Like even there I ran out of room. 2 and 2. Okay, so I have 1 group, 2 groups, 3 groups, 4 groups. I just missed 1 group. I still have 1 left over, so that's good. At least I still had that 1 left over that I thought I did. So 2 times 2 is 4. There's 4, so I get 16 square root of 2. So a little off there. And part of this is it's just going to take room, but other than that, it's fairly simple. Okay, so simplifying the following. So this one gets a little bit more confusing depending on how we look at it. So I'm going to go back a few slides and notice something. Well, I have an index of 2 right here. Check this out. My index number is the same as my exponent. Because those are the same, I can say that this is equal to x plus 4, and we're simplified. These cancel each other out, and I'm left with just my radicand number. All right, 4th root of 81. So I go 81 raised to the 4th root of 81. We're going to break this down. 9 times 9. 3 times 3. 3 times 3. So I'm looking for a number multiplied by itself 4 times. I have a group of 4 right there, and we get 3. All right, so that's the end of the lesson. If you have any questions, please make sure that you come and check with me or come and check with a tutor and ask those questions so that we can clarify anything. If you have any, and thank you for watching this video. Please stay tuned for the next one. Thank you.